madam. My name is Ling Ching Sam. My material number is 2710738, and this is my partner Chong Yowa, material number 2722033. So today we are going to talk about the topic of permutation. So permutation, we all know about permutation is stand for MPR, and this topic is basically discussing about the arrangement. Okay, so before we get into permutation, we have to learn what is factorial first. So this is the example of factorial. 5 factorial equals to 5 multiple 4 multiple 3 multiple 2 and multiple 1. And below is the 7 factorial example and 99 factorial example. So I will explain the permutation in 2 examples. So this is the first example. If there are 4 colors of book in a rack, how many ways that the books can be arranged in a row? So we have to calculate the ways to arrange the book in a row. How many ways that can we arrange? Okay, so for example, there are 4 places here. So for the first places, we can arrange red or green or blue or purple color books inside the first places. So there are 4 ways to arrange it. For example, we arrange red color book inside the first places. Okay, so we move to the second places. Now we only left 3 ways because we only left 3 books haven't arranged yet. The red color books already arranged inside the first places, so we only left 3 books haven't arranged yet. So which is the green color or blue color or purple color to arrange in the second places. So there are 3 ways. So for example, we arrange green color book in the second places. So we move to the third places. In the third places, we only have 2 ways, which is the blue color books or purple color books. So let's say we arrange blue color books in the third places, and we move to the last places. So now we only left purple color books 1 ways, which is the purple color books to arrange in the last places. So we arrange it. So now we can calculate the total ways by multiple 4 with multiple 3 and multiple 2 and multiple 1. So there are 24 ways to arrange the books in the rows. Okay, so as we can see, there are the formula is 4 multiple 3 multiple 2 multiple 1. Okay, so this is stand for what we learned in last slide. This stand for the 4 factorial. Okay, so let's move to example 2. So in the example 2, if there are 10 people and 6 chairs in a class, how many ways that can arrange the 10 people to sit in the 6 chairs? Okay, so now we have to calculate the ways to arrange 10 people to sit in the 6 chairs only. Okay, so there's a bit different with the last example. So for example, there is 6 chairs here. Okay, so for the first chairs, we have 10 ways because we still left 10 people haven't sit yet, and the first chairs doesn't have any people to sit, so we still left 10 people to arrange. Okay, so there is 10 ways to arrange. So let's say we arrange 8 people to sit in the first chairs. So let's move the second chair. So since we already have 1 people sit in the chair, so now we left 9 people haven't sit yet. So we have 9 ways to arrange it in the second chair. Okay, so we for example, we arrange people B to sit in the second chair. So now we have 2 people already sit in a chair. So now we left 8 people haven't sit yet. So we have 8 ways to arrange in third chair. Okay, so for example, we arrange C people to sit in the third chair. So we move to the fourth chair. So now we have 3 people already sit and 7 people haven't sit yet. So we have 7 ways to arrange in the fourth chair. So let's say we arrange D people in the fourth chair. We move to the fifth chair. So now we have 4 people seated and 6 people haven't seated. So we have 6 ways to arrange in the fifth chair. So we arrange E people to sit in the fifth chair, and we move to the last chair, which is still left 5 people haven't seated yet. So we for example, we arrange, so we have 5 ways. So for example, we arrange 5 people to sit inside the last chair. Okay, so now we can calculate so now the 6 chairs already full, already sit by 6 people. So now we can calculate the total way. So the total ways is 10 multiples 9 multiple 8 multiple 7 multiple 6 and multiple 5. Okay, so there is total 151,200 ways to arrange 10 people to sit in the 6 chairs. Okay, so this is what we based on what we learned. There are questions here. This is not a factorial, right? So the factorial should be followed by following multiple 5. By following we have the following by multiple 4, multiple 3, and multiple 2, and multiple 1. Then it will be the 10 factorial, right? So actually this is can be shown in here, which is the permutation formula. N factorial divided by n minus r factorial. Okay, what is n factorial? So the n factorial is basically stand for uh, 10 factorial, which is the 10 people. Okay, so since the 10 is the n is stand for 10 people, so the r is stand for 6 chairs, so it will become 10 minus 6 factorial. So it will be formed like this: 10 factorial divided by 10 minus 6 factorial. So it can be wrote like this also: 10 factorial divided by 4 factorial. So if you calculate in the calculator, you can get the answer 151,200 ways to arrange 10 people to sit in the 6 chairs. Yeah, that's all from me. I will pass to my partner.
Okay, my name is Chong Yua, metric number 272043. Okay, so now I will continue to talk about the example 3. Okay, so the question is, how many ways can the position of president and vice president be assigned from a group of 8 people? Okay, so the equation that we need to use for finding the permutation is NPR. Okay, so this helps us calculate the permutation. Okay, so the equation NPR is equal to n factorial divided by n minus r factorial. Okay, so for this question, 8 will be the n and 2 will be the r. Okay, so it will be 8 factorial divided by 8 minus 2 factorial. Okay, after 8 minus 2, it will be 6 factorial. Okay, so what actually is 8 factorial? Okay, 8 factorial is 8 times 7 times 6 times 5 all the way to 1. Okay, it starts with this number and multiply 8 by every integer all the way to 1. Okay, as what I say, so 6 factorial will be like above, which multiply 6 by every integer all the way to 1. Okay, so now we can start to calculate it. First, we can cancel the 6 times 5 times 4 times 3 all the way to 1. Okay, and now we left 8 times 7. Okay, and we know that 8 times 7 is 56. Okay, so 56 is the permutation for this question. Okay, for example 4, the question is how many distinct permutation can be formed using the letters of the word bookkeeper. Okay, so first we need to count the number of letters that are in the word bookkeeper. Okay, so there's total of 10 letters. Okay, so it's going to be 10 factorial on the top of the fraction, and on the bottom divide by the letters that repeat. Okay, so they have three letters that repeat, which is O have 2, K have 2, and E have 3. Okay, so there will be 10 factorial divided by 3 factorial, 2 factorial, and 2 factorial. Okay, so they're gonna be 10 times 9 times 8 all the way to 2 factorial. Okay, so for below, I'm going to leave the 2 factorial the same, not going to change it, and the other will write it as 3 times 2 times 1 and 2 times 1. Okay, so first we can cancel the 2 factorial. Okay, and 2 times 2 is 4. Okay, we can cancel it. Okay, and the last we can cancel the 3 as well. Okay, so we have left 10 times 9 times 8 all the way to 5. Okay, so the total will be 151,299. Okay, so there's the answer for this question. Okay, so for conclusion, all of the members are very effort in preparing this video presentation, and Lin Jingsheng is the leader for this assignment, and and he in charge for combined video presentation. Okay, so for me, which is Chongyua, is in charge for combine and arrange the presentation slide. Okay, so for all of the example question, that's fine by both of us, and example 1 and 2 is fine by Ching Seng, and example 3 and 4 is fine by me. Okay, so that's all from us. Thank you.